So we already started notes 7.5, which is exponential functions. Today, we're still on 7.5, but we did growth functions, and today we're going to focus in on exponential decay functions. We did growth functions, now we're doing exponential decay functions. It's still the same section though. So let's first begin by looking at certain visual graphs, and I want you guys to understand something here. This is not on your paper, by the way. This is just a graph. This is a growth function because from left to right, it grows away from the asymptote. Okay, so understand this, guys. When you look at a graph, you're going to look at it in the direction or in the way you read a sentence from left to right. So everybody, look at this graph from left to right. What's happening? Well, compare it to the graph compared to the asymptote. The distance, it looks like it's touching, but from left to right, it's growing. The distance is growing. The distance is growing. The distance is growing. The distance is growing, right? That distance is pretty big compared to over here, but it's growing. Over here, it's growing. So this is what we call a growth function. And you're going to have to do this on the next quiz or test. So please make sure you understand this, that this guy is a growth function. It technically has the asymptote at -3. Y equals -3. That's a k value of -3. So let's practice through a couple of graphs, and we're going to analyze them, look at them from left to right, and determine if they're growth functions or decay functions. Again, this one's growth because from left to right, the distance is growing, 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 and growing, right? How about this guy? Is that growth or decay? Decay, absolutely. Because if you look at the distance, I'll even draw it out here. It's 1, 2, 3, 4 units from the asymptote all the way up here to that point. But if you go from left to right, this guy is only 2 units away. This guy's only 1 unit away. This is half of a unit. This is a fourth, which is half of a half, and then half of that, and then half of that. That's a decay function. Why is it a decay function? Because from left to right, the distance decays. From left to right, the distance decays. So from up here to down there, it's getting smaller and smaller and smaller, okay? How about this guy right here? Is that a growth function or a decay function? That's a decay function because from left to right, look at that distance from this red dot to this red dot. It's pretty big, but from left to right, the distance gets smaller, it decays, smaller, it decays, smaller, it decays, smaller, it decays. What do you guys think? So that's a decay function as well. How about this guy right here, growth or decay? Growth, absolutely. This is growing, but in a negative direction. Okay, so right here, the distance is pretty close, but from left to right, the distance grows, the distance grows, the distance grows, the distance grows, right? So that's a growth function, but in a negative direction. If you're thinking, what do you mean a growth function in a negative direction? A real world example would be like, you guys have a bunch of credit cards, you don't know any money, you just got them, and then you just start going shopping, and you just shop, and you just buy a bunch of things. What's gonna happen? You're gonna grow, but in a negative direction. You're gonna grow in debt. So that's a growth function, but in a negative direction, okay? How about this guy, growth or decay? Growth for sure, right? Because from left to right, the distance is growing, 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 right? How about this guy, growth or decay? Growth, because from left to right, it's growing, 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 okay? How about this guy, growth or decay? Growth as well, growing, 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 growing. You always look at it the way you read a sentence from left to right, okay? So I hope we understand that. You're gonna have to identify growth and decay functions visually on the next assessment that we have on growth and decay functions. Now, this is not even looking at functions themselves. This is visually looking at the graph of the functions. But it's even easier when you're determining whether it's growth or decay when you look at it algebraically. We should all be comfortable with the form y equals a times the base to the power of x minus h, and then plus k. And in algebra 1, we don't even have a minus h. But this base is the growth or the decay factor. So you're going to be able to look at a function and know if it's a growth or decay without even analyzing the graph. So if this base is greater than 1, it's going to cause it to grow, which is a growth function. If this base is a value between 0 and 1, okay, then that's a decay function, okay? So what do I mean by that? Y equals, let's say, 2 parentheses 3 to the x minus 5. That is a growth function. Why? Because, so that's a growth function. Why? Because the base is 3. This guy over here, y equals 1/8 parenthesis 2 to the x plus 1. That's also a growth function. Why? Who cares about the a value? The base is what matters. The base is a growth function. Now, what do I mean by it's a growth function? Like on this first one, yeah, you got the base here, do the exponent, you ultimately have to multiply it by 2. If you multiply something by 3, it's going to grow. If you multiply something by 2, it's going to grow, okay? Now, if you look at this one, y equals, let's say, 1/2, no, not, let's say not 1/2, let's say y equals 6, parenthesis, 1/2 to the x minus 4. This is a decay function. This is a decay function. Why is that? Because the base is less than 1. The base is 1/2. Anytime you multiply something by half, it's going to decay, it's going to shrink. If I say 10 times half, it's going to decay down to 5. Half of 10 is 5. Okay, so it's really easy to determine growth or decay just by looking at the growth or the decay factor, which is the base of your function. So now that we know the difference between growth and decay functions, we could now dive into decay functions, and we could graph a couple of them, right? So everything I explained is right here in the notes. Steps to graphing a growth or decay function. Step 1, identify your asymptote, the horizontal line, y equals k. And there's 2 ways that I've been explaining for you guys how to graph this thing. One is to ignore the k value until you have coordinates. Then you shift all your coordinates 2 units down in this case because the k value is -2. Or you could include the whole thing and do an XY table and actually plug in inputs and outputs into the whole thing, which is a little bit more math, but it depends what you're more comfortable with. So if you wanted to ignore the k value for a bit, this is what you could do. Box that in, draw a quick XY table with consecutive integer inputs like -3, -2, -1, 0, 1, 2, 3. Plug in an easy number like 0. When you plug in 0, anything to the 0 power is 1. If you had like an a value of 2, yeah, you'd multiply 1 times 2, but there is no a value. It's just 1. So yeah, that's just a 1. So when you plug in a 0, you get out a 1. Now, at this point, you could take this output 1 and you could make it grow or decay to the next one, depending on the growth or the decay factor. Now, obviously, this is a value less than 1, that's decay. So you're going to take this 1, multiply it by 1/2, and it's going to decay to 1/2. And if you take that one and multiply it by half, 1/2 times 1/2 is 1/4. And if you multiply that by 1/2, it becomes 1/8. So obviously, it's getting smaller and smaller and smaller, right? Half of 1 is half of a half is a fourth, half of a fourth is an eighth, so it keeps getting smaller and smaller and smaller. It's decaying. Why? Because that's a decay factor of 1/2. Now, if going this way, it's decaying by half, that's like multiplying by half, multiplying by half, multiplying by half. What's the opposite of multiplying by half? Multiplying by the reciprocal of half. Multiplying by the reciprocal of half, that would be 2. So if you go 1/8 times 2, that's 1/4. What's 1/4 times 2? It's 1/2. 1/2 times 2 is 1. 1 times 2 is 2. Times 2 is 4. Times 2 is 8. You get all these beautiful points, and you could plot them. Let's start with the point 0, 1. 0, 1 is right there. Let's go to -1 and 2. That would be right there. Let's go to -2 and 4. -2 and 1, 2, 3, 4. It's right there. Let's go to -3 and 8. -3 and then 8, 2 units off the top of the graph, right there. And let's go over here with a +1 and 1/2. You go +1 and only halfway up. That is right there. And then +2 and a fourth of the way up, that's half of the half. +3 and an eighth, that's half of the fourth. And it keeps getting closer and closer. At this point, you're drawing your dots like if it's actually touching what it looks like to be the asymptote, which in this case is y equals 0, the x-axis. Now, why does it look like it's approaching that asymptote? Because I'm ignoring it. So if I ignored it, that means that this would be 0, and that would be the asymptote. But it's not. So if you ignored it, you come up with these points. It's really easy. You just keep multiplying by half or backwards multiplying by 2. You get those points. Then you got to shift them 2 units down. So every single one of these blue dots need to get shifted 2 units down, 2 units down, 2 units down. Hopefully you're using a different colored pen. 2 units down. And it's even better to start with your drawing your asymptote y equals -2. So let's go to -2. Let's draw our asymptote right there. It's a horizontal line crossing the y-axis at -2. And those red dots are going to forever get closer and closer and closer. You're going to draw it like if it's actually touching it. So the red dots are your graph, not the blue dots. So what are you going to do with the blue dots? Put like 2 X's on them. That way it's not confusing. It's the red graph, not the blue graph. So that's one option. And I hope you think, well, yeah, it's pretty easy. We ignored the K, came up with some XY values, used consecutive integer inputs, took that input of 0, got out of 1, multiplied the 1 times half, got half, multiply it by half, you get a fourth, multiply it by half, get an eighth. If you're confused with that stuff, you could just multiply with the calculator. 1 times half is half, half times half is a fourth with the calculator. Now going backwards, it's not doing half of it, it's actually doing the opposite of half, which is multiplying by 2. Or in other words, if you're multiplying by half going this way, then backwards it's multiplying by the reciprocal of half, which is 2 over 1, which is 2. So if you did 1/8 times 2, you would get 1/4 times 2, you get that, times 2 times 2 times 2. Plot those points, shift them down 2 units, you get your final graph approaching that asymptote of y equals k, which in this case is -2. Let's do it the other way where we actually include the -2. So I want to circle it because I'm including it. And I'm going to make an XY table, and I'm actually going to use the whole entire thing. I'm not going to ignore the -2, okay? So like, let's say you plug in the number, I want to plug in the 0, but towards the middle because I might have to plug in negative numbers. We're going to see where this ends up. When I plug in 0 up there, I end up with 1/2 to the 0. Anything to the 0 power is a 1, and 1 minus 2 is a -1. So when you plug in a 0, you get out a -1. And that's an actual point on your final graph. You don't have to shift if you're including that K value, okay? And if you actually graphed 0 on the X and -1 on the Y, you end up right there. Now let's pretend that you don't know what the graph looks like yet. So you might want to plug in like the number 1 and see where that takes you. But if you do plug in a 1, 1/2 to the 1 is 1/2, and 1/2 minus 2 is a -1.5. -1.5. So that is a point, but on quizzes, on Wayground, you're not going to be able to graph halfway down. But right here you can. If you went 1 over and 1.5 down, you'd be at that other dot. But you see, the problem is, if this is all you have, if you didn't go this way, then you're only seeing these 2 dots and you only see that asymptote. So yeah, I mean, you get the idea of what it looks like, but you don't know, you might go too far this way, or you might curve up too quickly. So you don't have the perfect curve that we have here in red. So in order for you to do that, you'd have to plug in more values. So if you plugged in 0 and you ended up right here, you want to plug in a value that's to the left of 0. Maybe like -1 or -2 or -3, right? So what would you like to plug in to the left of 0? Just give me a number to the left of 0. Anybody? That's on the right of 0. To the left of 0, it has to be negative, let's say -3, all right? -3. So if I plug in a -3 or a -2, I'll plug in all of them, who cares? Or even a -1. Let's start with -1. Plugging in a -1 right there, that's going to cause this to flip. Because the -1, you put it on the 1, that's 1 to the -1, it's going to come down. Put that -1 on the 2, 2 to the -1, it's going to go up. Or you could have just thought it, well, if this is a -1, you flip it first and it becomes positive. So that's really 2 to the +1, which is 2, and 2 minus 2 is 0. So when you plug in a -1, you get out a 0, and that's an actual point. -1 comma 0, that's a dot right there. I'm doing a yellow dot. I'm just producing the same red graph, but including that K value. So it's up to you if you want to include it or not include it. It's totally up to you. Plugging in -2 right there. Well, the negative would cause it to flip, so that'd be a 2 to the +2. 2 to the 2 is 4, and 4 take away 2 is 2. So when I plug in a -2, I get out a +2. And if you went to the coordinate -2, +2, you get to that other red dot right there. So you're going to end up with the same graph. It's just a different method. So it's totally up to you. Do you want to ignore the K value, come up with some points, and then shift it? Or do you want to include it and do a lot of math? And that's totally fine if you want to do it that way. And you'll get that same graph, okay? So I don't want to make this video too long. This one's easy. Let's do this one. Why is it easy? Because the K value is 0. So that means that the asymptote's at 0. So this is where our asymptote's going to be at the Y value of 0, which is the x-axis itself. Since there's no K value, there's going to be no shift. You just jump right in to the XY values, do consecutive integer inputs, plug in the easy number 0. Plug in 0, what do you get out? 1/4 to the 0 is 1. And then you got to multiply it by your A value, which happens to be positive 8. So 1 times 8 is 8. So when you plug in a 0, you get out an 8. Now, you could plug in a 1, a 2, a 3, a -1, a -2, but it's easier to just take this output and make it, do I make it grow or do I make it decay with this value? Does it grow or decay with this value? It decays because it's a 1/4. Anything times 1/4 gets smaller. So 8 times 1/4, if you did that on a calculator, it would give you 2. And then 2 times 1/4, that'll give you 2/4, which is 1/2. And then 1/2 times 1/4 is 1/8. As long as you understand that it keeps getting smaller and smaller and smaller. Now backwards, instead of multiplying by 1/4, backwards is multiplying by the reciprocal, which would be 4/1, which is multiplying by 4. That's how you get from a 2 to an 8. 2 times 4 is 8. 8 times 4 is 32. And it's pointless to go any higher because you already know that you can't even graph 1, 32. It's off this 10 by 10 graph. So let's plot these points. 0, 8 is up here. 0 on the X, 8 on the Y. 1, 2, 1 on the X, 2 on the Y is right here. 2 on the X halfway up. 2 on the X halfway up is right there. And then 3 and an eighth of the way up, it's even closer. An eighth is practically nothing. The next one will even be smaller, 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 smaller. There's my graph. Go ahead and draw it through your points. Draw an arrow. There is no shift, so I'm done. Now, I guess I forgot to mention domain and range and all that stuff on that one. So let's do this one first, then we'll go back to the other one and state the domain and range. So the domain on any exponential growth or decay function is going to be x equals all real numbers. That's like a free point on the next test. X equals all real numbers all the time. Why? Because it exists to the left and to the right forever. It's pretty obvious it's pointing this way. It's not so obvious because it's pointing up, but you got to keep in mind that it keeps going this way and further up, this way and further up. So if you're way over here, it's going to be way the heck off this paper, and you're going to be way over here, way off this paper, right? So it does exist to the left and to the right forever. That's why the domain is x equals all real numbers. It really does have all the x values in this decay function. What about the range? Well, the range is the y values, and this obviously points up forever, but it doesn't point down forever. None of the graph exists down here. Where does the graph exist? It exists above this asymptote, above the asymptote. So how do we say that it exists at the y values that are above 0? You're going to say y is greater than 0. And of course, we're talking about that asymptote y equals 0, the horizontal line. And for the y-intercept, how do you find the y-intercept? You set x equal to 0 and solve. So you plug in a 0 and you get out an answer. Now, I'm not going to do that because we already did that when we plugged in a 0, we got out an 8. So there's my y-intercept. That's the location of where it crosses the y-axis, 0, 8. Let's go back to the one we did before. The domain, again, x equals all real numbers. The range, y it's going to be either above or below the asymptote. Is this graph above the asymptote or below the asymptote? It's clearly above the asymptote. So what is that asymptote k value? That's -2. So it's above the y value of -2. You say y is greater than -2. And we just mentioned that the asymptote is y equals -2. That's a horizontal line crossing the y-axis at -2. And as for the y-intercept, that'd be 0, that'd be 0, -1. We already plugged in a 0, did all the math, got out a -1, 0, -1. Or you could visually see that it crosses right there at the location 0 on the x, -1 on the y. Any questions so far? No? Great. By the way, well, let's flip the paper over. And we have some more practice problems here. Which one would you guys like to see? Just to review, is this a growth or a decay function? Decay. Why? Because the base is 1/2 and multiplying anything by half is going to make it smaller. Is this a growth or decay? Decay, because multiplying by 1/3 is going to make it smaller. Who cares what the A value is? Is this growth or decay? That's growth because the base is 4. Multiply anything by 4, it's going to get bigger. Okay, so you guys get that idea. Let's go back. Which one do you guys want to do? 6? Let's do number 6. Why not? Okay, so again, I've been explaining 2 ways of how to do this. One way is to ignore the K value of -9. So I'm going to do that way. I'm going to do both ways, but ignoring the -9, you have your input-output table. You can have -3, -2, -1, 0, 1, 2, 3. Plug in the easy number 0. When you plug in the easy number 0 right here, anything to the 0 power is 1, and 1 times 4 is 4. Does that make sense? Okay, now again, we're ignoring -9, so you could pretend that it's not there. We're going to deal with that later. But if you want to find the next output, you could plug in a 1, do the math. You could plug in a 2, do the math. Or it's even easier to just take this output of 4 and make it decay by half. What's 4 times half? What's half? What's 2 times half? What's 1 times half? What's a half times a half? 1/4, right? And it keeps getting smaller. So we know that. Going backwards, if you're multiplying by half this way, if you're multiplying by half, because that's a decay factor, going backwards, you're going to multiply by the reciprocal of half, which is 2. So going backwards, if you say 1/2 times 2, that'd be 2/2, which is 1. 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. Obviously, you're not going to use that guy or this guy. That's off the 10 by 10 graph. But let's plot at least 0, 4, and -1 and 8. So let's start with 0, 4. Put a dot there. Let's go to -1 and 8 and put a dot there. Let's also plot 1 and 2. 1 on the X, 2 on the Y. Put a dot there. Let's plug in 2 and 1. 2 on the X, 1 on the Y. And then plug in 3 and only halfway up. So 1, 2, 3, and only halfway up. And you get the idea that this is going to infinitely approach the x-axis in this case because I'm ignoring the K value of -9. But these are our blue dots approaching the x-axis infinitely. So you could put dots like if it's actually touching, but you should know that it never actually touches, it just infinitely approaches. Now, this is not our final product. This is not our final graph. Why not? Because we've been ignoring the -9. So we need to take each one of these coordinates and shift them down 9 units. The easiest thing to do would be to start with your asymptote. And the asymptote is y equals -9, the K value. So if you draw your asymptote, you at the very least know that your graph from here is going to shift down and infinitely approach that asymptote. So you could actually put like your arrow right there. It's going to be on that asymptote. But you do have to shift all these points 9 units down. So 1, 2, 3, 4, 5, 6, 7, 8, 9. It's right there. Let me do this in red. Let's take the next point, shift it down 9 units. 1, 2, 3, 4, 5, 6, 7, 8, 9. Put a dot right there. And of course, if you wanted to, instead of counting 9 down, you could be like, how do I get from this one to this one? And just go 2 down, 1 to the side. So you could go 2 down, 1 to the side, and you get to that next point, which is the same thing as shifting down 1, 2, 3, 4, 5, 6, 7, 8, 9. Guys got it? And of course, from this one to this one, it's just down 1 to the side 1. So you could just go down 1 to the side 1 and put a dot right there. And then halfway, and then you know it infinitely approaches the asymptote. So here's your perfect graph in red. Those blue dots are not your final product. We just use that to get coordinates faster. Make sense? We could have included everything. Like we could have said, I'm going to do the whole stinking thing. Like I said, it's totally up to you. And make an XY table, including the -9. You could have plugged in like 0. Plug in 0 right there. 1/2 to the 0 is 1. 1 times 4 is 4. 4 minus 9 is -5. And you could do that on the calculator. And if you actually plotted this point in yellow, you'd get to 0, -5, which is that same exact dot. Now you need another point. You could plug in a 1 if you wanted to. Plug in a 1 right there. 1/2 to the 1 is 1/2. 1/2 times 4, half of 4 is 2, and 2 minus 9 is a minus 7. So when you plug in a 1, you get out a minus 7. And again, you could do that with the calculator. And if you went to the location 1, negative 7, you'd end up right there. So you already have an idea that your graph is going down towards the asymptote, which is y equals negative 9. But of course, if you wanted to be more precise, you'd need like another point that's on the left side of 0. So you could plug in like a negative 1 if you wanted to. By the way, on quizzes, on Wayground, with 2 dots and with the asymptote, it graphs it for you, okay? So it's going to be a lot faster when you do the homework on quizzes because all you need is 2 dots and the asymptote, and it'll graph it perfectly for you. So I hope this helps, and you guys could work on this, and you have the rest of the class to do the rest of these problems.